we have the cubic equation 2 times x to the power of 3 minus 2 is equal to 0. The first question that we need to solve is to solve the equation using corner scheme, and the second part it says to solve the equation numerically on the interval 0, 3 using the bisection method. So let's do A. We have 2x to the power of 3 minus 2 equal to 0. We need the coefficients of the polynomial. So this is 2x cubed plus 0x squared plus 0x minus 2 is equal to 0. We need these coefficients to run the iterative scheme. We have 2, 0, 0, minus 2, and we have also an initial guess r equals 1. 2 goes down with the elevator method. 2 times 1 is going to be 2. 0 plus 2 is going to be 2. 2 times 1 is going to be 2. Then 0 plus 2 is 2. 2 times 1 is going to be 2. So here I have the coefficients of a polynomial of degree 2. So 2x cubed minus 2 can be written as x minus 1 times 2x squared plus 2x plus 2 equal to 0. And from here I can take common factor 2. 2x minus 1 times x squared plus x plus 1 is equal to 0. From here I have x is equal to 1. And here I have a quadratic equation, x squared plus x plus 1 is equal to 0. The discriminant is b squared minus 4ac minus 3. It's negative. So my only root is x equals 1. And that's it. Now let's go to do the second part. We have to use the bisection method. Which says the following. We want to solve this equation on the interval 0, 3. So 0, 3, a1 is 0, b1, so that's my first iteration. b1 is 3. I evaluate at a1. If I evaluate at a1, this is gonna be minus 2, which is a negative value. fb1 is gonna be 52, which is a positive value. So once I have f of a1, f evaluated at a1 is negative, 1 is positive, so I'm gonna have a root there. So now I compute c1 is gonna be a1 plus b1 divided by 2. So that's gonna be 3 over 2. And now I evaluate at c1, f of c1 is gonna be f of 3 over 2. That's 19 over 4, which is a positive value. That is my first iteration. Now I progress to the second iteration. I have 0, I have 3, and here I have 3 over 2. So a0 is gonna be f of 0. It's gonna be minus 2, negative, and b2, a2 is gonna be 0, and f of 0 is gonna be minus 2. b2 is gonna be 3 over 2. F of 3 over 2 is 19 over 4, and it's positive. Now my new C2 is going to be A2 plus B2 over 2. 0 plus 3 over 2 divided by 2, that's 3 over 4, 0.75. Now I evaluate my function at 0.75 at 3 quarters, and it's going to be minus 1.15625. Okay, now I have to keep going with the iterations. Iteration number 3. Iteration number 3. So what I have from before is 0, 3, 3 over 4, 3 over 2. My A3 now is gonna be 3 quarters, and my B3 is gonna be 3 over 2. F of 3 over 4 is gonna be minus 1.15625, and F of 3 over 2 is gonna be 19 over 4. One is positive, one is negative, so we are good. They have to be, when you evaluate at A and B n, they have the values have to be of opposite signs. And now I have to find what is my C3, the midpoint. So I have A3 plus B3 over 2. So that's 3 over 4 plus 3 over 2 over 2. So my C3 is 1.125. I evaluate it at the value I evaluate the function at this C3, 1.125. So it's 2 times 1.125 to the power of 3 minus 2, approximately equal to 0.85. So if I evaluate it at the midpoint, you see is 0.85, but still I have to go because we computed the root before and it was 1. So I'm nearly there. Iteration number 3, and then we have to go to iteration number 4. Iteration number 4 is the following. We have 0, 0, 3, 3 quarters, 3 over 2, and here is 1.125, let's say. My A4 is gonna be 3 over 4, and my B4 is gonna be 1.125. My F of 3 quarters is negative value. My F of 1.125 is positive, if you do the calculations. So my C4 is gonna be A4 plus B4 over 2, the midpoint. So it's gonna be 0.75 plus 1.125 over 2, 0.9375. I evaluated at this F of 0.9375 is gonna be minus 0.352050781. So I have to progress, go iteration number 5. Iteration number 5. Remember when we solved with a corner scheme, the root was 1. So we are with this bisection method, we are making them intervals smaller and smaller, and this will apparently at some point give us a good approximation of the solution. 3 quarters, 3 halves. Here we have 0.9375, and here 1.125. So my A5 is gonna be 0.9375, and B5 is going to be 1.125. So F of, if I evaluate at this A5 is gonna be negative value, and F of 1.125 is gonna be a positive value. So my new C5 is going to be 0.9375 plus 1.125. 0.125 divided by 2, and this is gonna give me 1.03125. I evaluate it at this value here at C5, the function, and I have 0.19. Let's go and have the last iteration. Let's do one more iteration, iteration 6. My new A6 now is going to be 0.9375, and B6 is going to be 1.03125. C6, A6 plus B6 over 2 is going to be my new midpoint, and roughly is 1.97 over 2, and this is roughly 0.985. I evaluate at this C6, so it's gonna be 2 times 0.985 to the power of 3 minus 2, and this is roughly minus 0.089. So it approaches close to 0. So you see we are making the interval here smaller and smaller, and this is going to be my x6 after 6 iterations, 0.985. And the exact solution x exact is equal, that's the numerical solution, that's the exact solution. You can see that these values are very close, so you can keep iterating, and if this difference is very small, then you stop the iterations.